Hi guys, what we're going to be looking at today are graphs of polynomial functions. Okay. Here you're being asked to identify the leading coefficient, degree, and end behavior. So what you will have looked at in class first is the graphs of polynomial functions. Okay. In general, so you'll have that to look at. Okay. New to you guys will be this quartic and quintic functions. Okay. Don't get overwhelmed. Just take good notes. Next, if you remember from the first week of school, we did talk about end behavior. Okay. Now you will have time to copy this guy down. Let me go and add something that's going to be very valuable to us. Okay. Might not be obvious now, but it will be. Okay. Now, of course, you can read the details, but okay, some of these symbols may be a little too complex to look at first. So here's a little code. Okay. For this box, my focus are the arrows. Okay, so I'm going to do something like this. Right? The left side's pointing this way, the right side's pointing that way. Okay. Here, the left's doing that. Okay. The right is doing that. Here on this one, okay, the left is going up and the right is going down. And this one, both arrows are going down. Okay. Alright, so we're going to go and use this in a little bit here. Okay. Now in this case, they want us to identify the leading coefficient. Pay attention. The leading coefficient, okay, to find the leading coefficient, you need to find the x with the highest degree. So here it is. Okay. The leading coefficient is the number in the front, so it'd be -4. Okay. So leading coefficient is -4. The degree there, okay, so this is my focus, is 3. And the end behavior, okay, which we just discussed a little bit ago. Let's go over here. Okay. Now notice I'm going to have to use this information, right? The leading coefficient is negative, and the degree is 3. So watch this. Okay. Now in here, let's go and I'll help you out here, and remember that any number greater than 0 is going to be positive. And any number less than 0 is going to be negative. Okay. So we're going to use this now, so that if we have a negative leading coefficient and an odd degree, right? So let's highlight this part: negative and odd. Okay. So notice how here it says odd, negative. So here it is. Now I can go ahead and use these to respond to the end behavior. Okay, so let's go and do that. Now this says as x goes to positive infinity, what is y doing? Okay, it's going down this way. This one says as x goes to negative infinity, left, what is y doing? Okay, so although it looks complex, you get to, as long as you understand the table, you can just copy. Okay. So let's go and do that. Let's see here. Let me see if I can give a split screen. Okay. So where are we? Okay. This is what I would do for end behavior. End behavior. I'm going to put down x approaches positive infinity, p of x, and I'm copying this right here. Okay. Approaches negative infinity, and as x approaches negative infinity, p of x approaches positive infinity. Okay. All right, there's the second one. You can try that, kind of check your understanding. Okay. The second thing you'll be doing is identify whether the function graph has an odd or even degree and a positive or negative leading coefficient. So it looks pretty tough, okay, but with that system that we just gave you, it's going to be very helpful. Okay, so look at the end behavior of this one. Okay, you can tell that this arrow is kind of heading in this direction, and this one is heading in that direction. Okay, so all you have to do is find a match. Okay, so left down, right up. Left down, right up. Okay, so this is the winner, so I'm going to go with odd, right, odd degree and positive leading coefficient. What is it asking for? Okay, so odd, okay, and I'll call that D for degree, and a positive or negative. And what do we say? Let's double check. So left down, right up. Left down, right up, and here's the coefficient, it's positive. So leading coefficient is positive. Alright guys, thanks for your time.